Hello everyone, this is Shubham Bharat, student from Rajaram Bapu Institute of Technology. Here we'll get some basic knowledge about interfacing Max Botics ultrasonic range sensor with Firebird 5 Atmega 2560 robot under the guidance of Professor Subodh Ingeshwar, Department of Electronics and Telecommunication from Rajaram Bapu Institute of Technology. As we know, Firebird 5 is the latest robot of Next Robotics. Here we will learn how to interface this module with the bot. Um, uh, Here is some introduction about the sensor MaxBotix EZ4 ultrasonic range sensor, which can measure the distance up to 6 meters. It has a very narrow beam angle, which makes it most suitable for range sensing application on the mobile robots. EZ4 sensor gives out distance reading as analog voltage or serial data. This sensor is available in customized sensor module kit for Firebird 5 robot. EZ4 sensor has 7 pins for interfacing. Out of these pins, only input means plus 5 volt ground, GND, RX receiver, and AN are used for interfacing. Here we are interfacing analog signal with Firebird 5 Atmega 2560 robot. Now there are some pin configurations for this sensor. GND ground plus 5 VCC operates on 2.5 volt to 5.5 volt DC. TX transmitter output delivers asynchronous serial with an RS-232 format when BW is set low. When BW is set high, it sends a single pulse for chaining. RX receiver, this pin is internally pulled high. The EZ4 will continually measure range and output if RX data is left unconnected or held high. If it is held low, the EZ4 will stop ranging. Bring high for 20 microsec or more to command a range reading. AN outputs analog voltage with a scaling factor of VCC by 512 per inch. A supply of 5 volt yields 9.8 meter volt per inch approx and 3.3 volt yields 6.4 meter volt per inch approx. PW, this pin outputs a pulse width representation of range. The distance can be calculated using the scale factor of 147 microsec per inch. BW leave open or hold low for serial output on the TX output. When BW pin is held high, the TX output sends a pulse instead of serial data, which is suitable for low noise chaining. Now we'll see how mounting is done, mounting of sensor on Firebird 5. EZ4 sensor is connected to the robot using 16-pin FRC cable, flat ribbon cable. This cable is soldered on the sensor and sensor is mounted on the mounting plate as shown in figure. Mounting this sensor mount this sensor mount on the robot. Uh, Make sure that keep 3 mm space between robot's top acrylic plate and sensor mount and pass FRC cable in between the spaces. Route the FRC cable and tie with cable tie on the robot's top acrylic plate as shown in figure. Insert the FRC cable in the servo pod socket. Sensor interfacing with the robot. The given figure shows the interfacing of the EZ4 sensor with the bot. AN pin gives analog voltage proportional to the distance between obstacle and robot. RX pin, which is triggered to take the sensor reading. If this pin is kept at the logic 1, then sensor will take continue reading at 15 meter second interval. We can also take a single reading by giving the single pulse of 20 microsec to the pin whenever required. In this case, the last reading is latched as analog voltage on AN pin till the next trigger is applied. EZ4 sensor is interfaced to the servopod socket on robot as shown in figure. Now, the given table shows the pin configuration of the servopod socket. Uh, Pin numbers 1 and 2 are not used. 3 and 4 servopod 2 are connected to Atmega 2560 ADC channel 15 is connected to analog output of ultrasonic range sensor. Pin number 56 GPIO Atmega 2560 PB4 pin is connected to RX pin of ultrasonic range sensor for triggering at 50 millisecond interval. And directly pin number 11 and 12 are ground, and 13 and 14 VSYS connected to plus 5 input voltage, and others are not used. Now we'll see some application example code. In the application example, ultrasonic interfacing FBV, distance between obstacle and robot is measured and displayed on LCD. In this code, RX pin is triggered with 20 microsec pulse at an interval of 150 millisecond to get the reading from the ultrasonic sensor. After reading the analog value and doing analog to digital conversion, distance in centimeter is on the displayed on the LCD. Now we see calculation for displaying distance in centimeter. EZ4 ultrasonic range sensor outputs analog voltage with a scaling factor of input voltage VCC by 512 per inch. With 5-volt supply, we get resolution which is equal to 9.8 millivolt per inch. As we know, 1 inch is equal to 2.54 centimeter. Resolution is achieved in centimeter is 0.00385 volt per centimeter. Atmega 2560 microcontroller ADC resolution with 10 bit is equal to 5 by 1024, which gives 0.00488 millivolt per ADC step. For distance in centimeter, ADC steps is uh, multiplied with 0.00488 divided by 0.00385, which is resolution. It gives ADC steps into 1.267, where 1.267 is the constant multiplier to multiply with ADC output with 10-bit ADC resolution to get the distance in centimeter. After this, to run the application, load ultrasonic interfacing fb.hex file on Atmega 2560 microcontroller of Firebird 5 Atmega 2560 robot. Also, for if you want to know how to load the file, please prefer manual. Now keep the obstacle in front of the robot. The robot will show the distance measured in centimeter on LCD mounted on the robot as shown in the figure. This was the small tutorial about the basic knowledge of uh, ultrasonic range sensor for Firebird 5 at Mega 2560 robot. Thank you.